This is question 12 from exercise 9.9 in Newton Size Project Maths 3a. We've defined the sum of the arithmetic series 2 plus 5 plus 8 plus ... plus 59. So what we can read so far from this is we can tell what our first term is, which we would use, which would be our a and any of our formulas that we're going to use. So our a, our term 1, that's going to be 2. That's nice and straightforward. And we can figure out our common difference because the difference between 2 and 5 is 3, and the difference between 5 and 8 is 3, and we know that this is an arithmetic sequence, which means that d is going to be equal to 3. Now our formula for the sum of an arithmetic series is Sn is equal to, and then it is n over 2 multiplied by 2a plus n minus 1 times d, like that. So you notice that from our formula there are three variables, a, d, and n, and we don't have the n yet. We need to know what the n is. N is the position number for every single one of these terms in the sequence. So for example, 2 right here at the start, that's t1, so n equals 1. And 8 is term 3, so n equals 3. But we need to find out where 59 is in the series. So the way we're going to do that is we're going to first of all get the general term for the numbers in the sequence. So we're going to find Tn. Our formula for Tn is a plus n minus 1 times d. And if we put our values in for that, we're going to get the T of n is equal to 2 plus n minus 1 times 3, which is going to be equal to 2 plus 3n minus 3. So Tn is going to be equal to 3n minus 1. And remember, we're trying to solve for n here because we already have a and d. So what we're going to do now is we're going to set this T of n equal to 59 and solve out for n. So we're going to say 3n minus 1 is equal to 59, which means that 3n is equal to 59 plus 1. So 3n is equal to 60, which means n is equal to 60 over 3, n equals 20. So what we have found here is that 59 is the 20th term in this series. That's what we have figured out over here. The equation Tn, I'm putting a box on this now, this bit here, that's the general term to find a number if you know the position. But if you know the number, you can use it to work backwards to find the position itself. So if we know the position, we put that number in for n. So in other words, if we put in 3 to this equation, we'll expect to get 8 out. So that's what happens if we know the position. But when we don't know the position in the sequence, and we want to find out what it is, we set this equation equal to the number, which is what we've done here. So we set 3n minus 1 equal to 59, and we solve for n. And we found out that 59 is now the 20th term in the sequence. Which means in order to find S20, which is what we've been looking to find, we can now use this formula over here on the right, along with our A and our D from the top. So it's going to be 20 over 2 multiplied by 2 times 2 plus 20 minus 1 multiplied by 3, like that. So we just use this formula on the right and we subbed in our values for A and D and our value for n that we found out here on the left. If we work this out, it's going to be 10 times 4 plus 19 times 3. So that's going to be equal to 10 times 4 plus 57. So it's going to be 10 times 61. So it's going to be equal to 610. So the sum of that arithmetic sequence arithmetic series is going to be 610. That is what you would get if you added up all the numbers from 2 to 59 in this series. And that is that.